Episode 6, we're continuing to work on a utility that we started in Episode 1 called Big Bad Blocks. It helps me find defective sectors on slightly broken 8TB hard drives I receive for free for Christmas. To get the context, I would say go watch Episode 1, but production values have increased a lot since Episode 1, so I'd say watch them in reverse. So by the time you arrive at Episode 1, you're invested enough to put up with me talking like this. Today we're doing cleanup. We only use the search method of status pattern. Perfect use case for the walrus operator. We can replace all of this using the built-in iter function. This lesser used form of iter takes a callable and a sentinel. It returns an iterator that repeatedly calls the callable until the callable returns none, and then it stops. Fun fact, the asynchronous version of iter, aiter, doesn't have this callable sentinel alternative form. I don't know why. Let's always fail if the output path exists, not just when we're using the default output path. Device.path is already a path, missing return type annotation. The public API to this module is just the main function, so all the other names should start with an underscore to indicate to any users that that's my implementation details. Does that look better? Nope, but Python doesn't really have a way of declaring what you want to export from a module, so that's the best we've got. Here comes the worst part. Because all of these imports don't start with an underscore, they're going to show up as part of our public API. So we have to alias them all to their name with an underscore at the start. I'm going to do this using a vim macro. Start with the cursor in the middle of a word. We're going to record a macro to register U by pressing Q, U. Copy the word we're in by saying yank inner word. Y-I-W. Go to the end of the word with E. A for append. Space. A-S. Space. Underscore. Escape. P for paste. Job done. Stop recording with Q. Let's try it out. Press @U. Beautiful. Now we get to go through the program and add underscores to the start of literally everything. What's this guy's problem? Oh, I put the underscore in the wrong place. A while back, I said that Pydantic didn't natively support pathlib's path object, and you had to put arbitrary types allow equals true in the config dict. That's not true. I was getting confused. I was thinking of trio.path. Some of these imports are just used during type checking. We don't need them during runtime. So we can use if type checking, and then only import those symbols when we're type checking. Let's just check it still runs. Yeah, we're looking good. Done should always have 2 decimal places. No more, no less. Control-C is really ugly in this program because it's a valid way to exit the program, but every time we do it, we get this huge traceback. We could use context-lib's suppress to suppress the keyboard interrupt, but that has a downside. If I Control-C the program now, we don't get the ugly traceback, but look, the exit code was 0, meaning success, but it should be non-zero. To solve this, we have to let the keyboard interrupt exception go unhandled so that the interpreter deals with it and exits with the correct code. The only bit we want to suppress is it printing out the traceback, and we do that by overriding sys.execHook. When an exception goes unhandled, it's passed to sys.acceptHook, and it's this default hook that's responsible for printing out that ugly backtrace. What we do is intercept those unhandled exceptions, and if it is keyboard interrupt, then we just ignore it. And Control-C. And our exit code was 130. Failure. Spot on. Let's add a force option that ignores this check, just to make testing easier. There's an underscore there. Get rid of that. I know people aren't keen on it, but I quite like Python's ternary operator. Well, I don't like it, but I don't mind it. Makes me sneeze as well. When we launch the program, there is an output immediately because we have to wait for the underlying utility bad blocks to print out a status line. That pause comes from here where we open the live table because we're not passing a renderable, so we have to wait until someone calls update. What we need to do is pass in a 0 or initial status that we make up ourselves. It's going to be quite hard to perceive, but we should see a status of completely 0 immediately. Yes! It's time to add safety baubles to our data classes. I've made end and status completely immutable because we can't change the status that someone else gave us. I mean, we can technically, but I mean like ethically. Our program Big Bad Blocks is shaping up to be something quite beautiful. It's almost time for it to fly the nest, and we're going to move on to building something else. But before that, each time around the loop, we're popping all of the statuses out of the buffer and updating the table, but really, all we need to do is find the latest status in the buffer and just do that update. So I've had a wild idea. What happens if we reverse the buffer and then search it backwards? Now that does mean reversing this regular expression so it works backwards, and I think I've worked out a way to do that automatically, but that's for another episode.